Hi all, this is Orgho from Barton World. So today we'll start the insertion sort, and basically we'll discuss the basic concept of the insertion sort along with the pseudocode analysis. At the end we'll wrap it up with the complexity analysis of the insertion sort. So let's start. So here we have taken an array of 6 elements. You can see 23, 42, 4, 16, 8 and 15. And also depicted the positional values of this array, which is the 0th position, 1st, 2nd, 3rd, 4th and the 5th positions of this array. So the basic idea behind the insertion sort is that we have to divide the list into two portions. One is sorted, another one is unsorted. Okay, and in each step this algorithm will shift the elements from the unsorted portion to the sorted portion, so that the sorted portions become completely sorted all the time. Okay, as we move, we will shift each number one position down the place for the room of the new number. So let's start with the example. So here is the list of elements. 6 elements are in the there. As I said, we have to divide the number into two portions. One is sorted, another one is unsorted. So as you can see that all these numbers are neither in ascending or in descending order. So all those are in unsorted positions right now. And we don't have any element in the sorted portions right now. So let's take 23 in the sorted portions, which is the start and the end of the sorted portion. Okay, so now what is the rule? We have to take the first element from the unsorted portion and place it in the sorted portions in such a way that sorted portions always become sorted. Okay, so what we have to do? We have to take 42 and compare it with 23. We are comparing it with 23 as it is greater. So 42 will simply append to the right side of the 23, and then 42 we have taken and it will come to the right side of the 23, and then we will have 2 elements in the sorted portions and rest of the 4 elements are in the unsorted portions. Fine. So now it looks like this. So again we have to take 4, that is the first element from the unsorted portion, and we have to place it in the sorted portion in such a way that the sorted portions become sorted all the time. So what we will do, we will take 4 and compare it. What we have done, we have taken 4 and compare it with 42. As 4 is less than 42, so we will shift 42 right. We have shifted 42 right and make the place empty for the new element, and again compare 4 with 23. As 4 is again less than 23, we will shift 23 right and placed 4 here. So now in the sorted portions are having 3 elements, and in the unsorted portions there are 3 elements. Now we have to take the first element from the unsorted portion, that is 16, and we have to place this element in the sorted portions in such a way that sorted portions become sorted all the time. So let me take 16 and compare it with 42. So we have taken 16, and while we are comparing with 42, we can see that 16 is less than 42. So we will shift 42 here and keep 16 here. We have shifted 42 here and kept 16 here. Now we are comparing 16 with 23. As 16 is less than 23, we will shift 23 here. Let me shift it there. We have shifted 23 there and kept 16 here. And again we will compare 16 with 4. As 16 is not less than 4, we will stop here and place the 16 here. So you can see now the sorted portions are having 4 elements and the unsorted portions are having 2 elements. Okay, so now again we have to take 8 from the unsorted portion and place it in the sorted portion in such a way that sorted portions remain sorted all the time. So let me take 8. We have taken 8 and now we are comparing 8 with 42. As 8 is less than 42, 42 will again shift right side. So we have shifted 42 to the right side, make that place empty for the new element, and again comparing 8 with 23. As 8 is again less than 23, so we will move 23 this side and kept 8 here. Again we are comparing 8 with 16. Again 8 is less than 16. So we will again shift 16 to the right side and kept 8 here. So then while we are comparing 8 with 4, 8 is not less than 4, so we will stop here and place the 8 here. So now these 5 elements are sorted. You can see 4, 8, 16, 23 and 42 are sorted right now, and there is one element in the unsorted portion, that is 15. So now we will place 15 in the sorted portions in such a way that sorted portions become completely sorted. So we have taken 15 and comparing it with 42, 23, 16. So like the way we have done it before. So ultimately 15 will come this position and all the other elements will be shifted sorry, to the right side. So now there is no element in the unsorted portions, all the elements are in the sorted portions. Fine. So this is how the algorithm is work. So now we will discuss the pseudocode analysis of this algorithm. So you can see this is the pseudocode of this algorithm. So in the line 1 we are iterating over all the elements in the list except the first element. Why? As the first element in the unsorted portion simply become the first element in the sorted portions. Fine. Now come to the second and third line. So here we are keeping track of the current place of the unsorted portions. Element is the element that we are moving in the sorted portions from the unsorted portions, and j is the index of that element. And come to this line. So in this line 4 we are iterating in the sorted portion from right to left, and we will stop when the sorted list become completely sorted after inserting the new element from the unsorted element. Here in this line 5, here we are shifting the element one place right for creating space for the new element, and in this line 6 we are updating our counter to move left through the sorted portions, and finally in this line 7 we are inserting the element in the sorted portion of the list. Fine. So now take a look how long the time this algorithm is taking. So as you can see that this algorithm basically is there is one loop here and there is another loop is there, means this loop is nested over this loop. So this is running n times and this is also running n times. So we can think that we have to iterate over unsorted array one by one and place them in the sorted array, and for every element in the unsorted array we are comparing that element with all the element in the sorted array. So total number of comparisons are n star n equal to n square. So we can see that this is basically order of n square. You can also think it like this way. Let me explain you. See here, when let me come here. See here, for the first time when we are comparing 42 with 23. That was the first element in the unsorted array with the sorted array. We were comparing it with 1 times. Again, when we were comparing 4 and try to place 4 in the sorted array, there were 2 comparisons. Initially it were 1 comparison. Now we are having 2 comparisons here. So again, when we have to think about 16 there, and we have to place 16 in the sorted portions, we have to compare 16 with the 3 remaining elements in the sorted portions. That means this loop, that we can think that for the first time it is basically running, it is basically taking 1 comparison. Then for the second element, in order to place the second element in the sorted portions, we have to compare it 2 times. in order to place the third element in the sorted portions, we have to compare it with the 3 existing elements in the sorted portions. Like this way it's going on. So we can say that total number of comparisons are sum over I equal to 1 to n minus 1 over n. So that will eventually give you n into n minus 1 by 2. So that will become n square by 2 minus n by 2. So now this n square by 2, will consider this n square by 2 part only, as this part you can see compared to the n square it is negligible. So we can say the order of the algorithm is order of n square. Fine. So now consider another case, that is when the element is, all those elements are sorted, means the list that over that you are trying to implement this algorithm, the list is completely sorted. That means suppose you are having a list like this 4, 8, 15, 16, 23 and 42. In this case what will happen? We will simply build the sorted portions from left to right, means this loop here, this loop will not work, means no shifting, no positional change will happen, just this loop will work here, and we will simply build the sorted portion from left to right. So this will give you total number of this is the best case of n comparisons only. So you can say that this is the omega of n in terms of best case. So for the best case it is taking n comparison, and for the average case or worst case it is taking n square. Hope you understood. So this is all about the insertion sort. So thank you. If you have any other things to know, you can post us, we'll come to that topic, and obviously hit a like, thumbs up, share this video if you like, and comment here, subscribe our channel. Thank you.